Hello everyone, welcome back to my general chemistry mini lecture. Today we will talk about the empirical formula and molecular formula. And we will talk about how to calculate the formulas. Before that, we will talk about the mass percent calculation, and that's related. Now this is a question shown as example. What is the mass percent of each element in sodium bicarbonate? And this is baking soda. To answer this kind of question, we first need to calculate the molar mass of this formula. The molar mass of this baking soda: 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. So the summary of this mass equals 84.01. That is the molar mass of this sodium bicarbonate. Then you can calculate individual elements mass percent. For the sodium, if you look at the formula, there's only 1 sodium in the formula, so just 1 sodium's molar mass, 22.99. You can find that from periodic table. Divided by molar mass of this formula, the percentage is 27.36%. That's mass percent of sodium in baking soda. Now, the second element you can calculate is hydrogen. Hydrogen, there's also just 1 hydrogen. Molar mass of 1 hydrogen is 1.01 divided by the total molar mass. The percentage is 1.2%. The third element here, carbon, the mass percent equals, since this is also just 1 carbon in the formula, so just the molar mass of 1 carbon, 12.01, divided by the total molar mass. The percentage is 14.3%. The last one is oxygen. Now, oxygen, there are 3 oxygen. Look at the subscript. There are 3 oxygen atoms in this formula. So you have to use 3 multiplied with the molar mass of the 1 oxygen divided by molar mass. The percentage is 57.14%. Okay, so this is how you calculate the mass percent of each element. I'll give you another example. Calculate the mass percent of all elements in glucose. Okay, so follow the same strategy. Calculate the molar mass first. 6 carbon, 12 hydrogen, 6 oxygen. So the molar mass of the glucose is 880.2 grams per mole. Then we have 3 elements. The first one is carbon. 6 carbon times the molar mass of carbon divided by molar mass of the formula, and then the percentage is 39.99%, about 40% carbon in glucose. And then hydrogen, there are 12 hydrogen, 12 times molar mass of hydrogen, 1.01, divided by the molar mass of glucose. The percentage is 6.73%. The last one is oxygen. There are 6 oxygen, so 6 times 16, that's the molar mass of oxygen divided by 180.2. The percentage is 53.27%. Okay, so as long as you know the formula of the compound, you can calculate the mass percent of each element based on the molar mass. Okay, now let's talk about the 2 different formulas: empirical formula and molecular formula. Empirical formula shows the simplest whole number ratio of atoms in the formula, in a compound. Okay, and molecular formula shows the real number of each type of atoms in the compound. They are related. Usually the molecular formula equals the multiple of empirical formula. This n is the number of units of empirical formula in the molecular formula, and the n must be positive integer. For example, 1 or 2 or 3 or more. I'll give you some examples of the 2 different formula. They can be same, they can be different. Benzene is an organic solvent, and the molecular formula is C6H6. The empirical formula is CH. Basically, it's 1 carbon, 1 hydrogen, because the simplest ratio of 6 to 6 is actually 1 to 1. So it's 1:1. That's the empirical formula. Another compound, ethine, the molecular formula is C2H2. The empirical formula is also CH because 2:1 is 1:1. I'm sorry, 2:2 is not the simplest ratio. So 2:2 is actually 1:1. So you can see a different compound they have with different molecular formula could have the same empirical formula. Third example, water. The molecular formula and the empirical formula are the same. It's 2 hydrogen to 1 oxygen because 2:1 is already the simplest whole number ratio. Hydrogen peroxide is H2O2, so the empirical formula will be HO because 2:2 simplified as 1:1. Glucose, the molecular formula is C6H12O6. And empirical formula will be CH2O because 6 to 12 to 6 can be simplified as 1:2 to 1, 1:2 to 1 as the whole number ratio. Dinitrogen tetroxide. The molecular formula is 2 nitrogen, 4 oxygen here. And empirical formula will be NO2 because 2 to 4 can be simplified as 1:2. Last example, I'll show you propene. The molecular formula is C3H6. Since 3 to 6 can be simplified as 1:2, so the empirical formula is CH2. So the N for each example here, the N is the number of units, or you can say the multiple of empirical formula. For benzene, the N is 6. See, empirical formula times 6 will be the molecular formula. For ethine, the N is 2. You can see the multiple. For water, it's 1. It's the same. Hydrogen peroxide is 2. And glucose is 6. So this number basically shows how many units of empirical formula in the molecular formula. For this dinitrogen tetroxide, it's 2. For the propene, is 3. Okay, keep in mind that we will use this kind of knowledge when we calculate molecular formula from empirical formula. Now, let's look at the example of the empirical formula calculation based on the percent composition of all elements. Example, calculate the empirical formula for a compound with the following percent composition of all elements. Carbon is 33.6%, hydrogen is 6.61%, oxygen is 59.7%. The tricks for this kind of question is first, you assume 100 grams of sample because this will give you a much easier calculation. If you have 100 grams sample, then you will have each element, the number of mass will be the same as the percentage. For carbon, it's 33.6 grams, hydrogen 6.61 grams, and oxygen 59.7 grams. So just for convenience. And of course, you can assume a different amount of sample, but then this number will be different with the number of percentage. Now we can convert this each element's mass to mole. The mole of carbon equals mass divided by molar mass of carbon. It's 2.8. Mole of hydrogen is the mass divided by molar mass of hydrogen is 6.54. The mole of oxygen is 59.7 divided by molar mass of oxygen is 3.73. Now we have 3 number of the moles of the 3 elements. We need to find the smallest number. 2.8 is less than the other 2 numbers, so we have to use this 2.8 to divide the 3 number. Same, okay? All divide by 2.8. Then we have 1, this is 2.34, this will give you 1.33. And this basically is the subscript of the 3 element in the empirical formula. Because the subscript must be whole number, so we need to multiply with something to convert all of them to whole number. For this example, this should multiply with 3 to all number. And this will be 3, this will be 7, this will be 4. Why? Because if you look at the decimal number, 0.34, 0.33, basically they are 1/3, so 1/3. So you multiply with 3, then you can convert this whole number. Of course, you have a little bit off, round. So, but you will find the 3 is the number you need to multiply. So then the empirical formula will have 3 carbon. How do you know that? That is 3 carbon, 7 hydrogen, and 4 oxygen, So the empirical formula will be C3H7O4. We can also calculate the empirical formula from combustion analysis. For example, combustion of a hydrocarbon. When you see that, that means this compound only consists of hydrogen and carbon, no other element. The combustion will produce 3.45 grams carbon dioxide and 1.59 grams of water. So that will be analyzed when you do the combustion analysis. And then calculate the empirical formula of the compound. So if we want to solve this kind of question, we also need find the moles of carbon dioxide and the moles of water. Okay, that's the first step. First step, find the mole of carbon dioxide, mass over molar mass. So this is the mass given of carbon dioxide. This is the molar mass. You calculate it based on the formula, 44.01. And the division give you the moles of carbon dioxide. And since the carbon in carbon dioxide is just one atom, so there's only one atom of carbon in one molecule of carbon dioxide. So the ratio is basically 1 carbon in 1 carbon dioxide. That's basically the mole ratio. And so if you have a 0.0784 mole of carbon dioxide, you should have the same number of mole of carbon, 0.0781, because there's only 1 carbon in the formula. Now, that is important. We'll use this for next step, for following step. Now, mole of water will also be calculated by the mass divided by molar mass of water. You get 0.0882. Now, you need to find the number of moles of hydrogen. Because there are 2 hydrogens in one water molecule, so you need to multiply with 2 with this the moles number of water. Then you can get the number of moles of hydrogen. That's double of this number. It's give you 0.176 mole of hydrogen. Now this 2 number, it's used for next step. So now we have the mole of carbon, mole of hydrogen, just calculate it. And then we need to convert them to whole number. So we need to find the less number here. So this is less than 0.176. So you have to use this 0.0784 to divide both number. So of course this will give you 1, this one give you 2.25. So now we need to convert them to whole number. So basically they are the subscript of carbon and hydrogen, must be whole number, cannot be decimal number. So now you need to multiply with 4 apparently, because this is the 0.25 is a quarter. So you multiply with 4 will convert to whole number. So this will be 4 and this will be 9. So empirical formula will be C4H9. That's 4 is the subscript of carbon, 9 is subscript of hydrogen. Okay, so those are examples of how to calculate empirical formula. Now let's talk about how to calculate molecular formula. Okay, so you will see sometimes you do need first calculate empirical formula and then calculate molecular formula. This example, find the molecular formula for a compound with molar mass of 213 grams per mole and the following percent composition, and give you 3 different mass composition of the carbon, hydrogen, and the nitrogen. So actually I'll show you 2 different ways. The first way is to calculate empirical formula. So follow the same strategy, assume 100 grams of sample, then each element's mass will be the same as the percentage. So 33.8 grams carbon, 7.02 grams of hydrogen and 59.2 grams of nitrogen will be in 100 grams of sample. Then convert all the mass to mole, mass divided by molar mass of carbon, the mass of hydrogen divided by molar mass of hydrogen, mass of nitrogen divided by molar mass of nitrogen, give you the moles of these three elements. Find the least number, which is 2.81, and then use this number to divide the three number. So you get 1, and this will be 2.47, this will be 1.51. And you need to convert this to whole number. So it seems like the multiple is 2, because you can convert this to 2, you can convert this to 5. 1.5 times 2 is 3. Again, there's a little round off, okay? So now you have empirical formula. C2, that's the carbon, 5 hydrogen, 3 nitrogen. C2H5N3. Now we have the empirical formula. We need to find the unit number of the molecular formula, that is N. So to calculate that N, the multiple of the empirical formula, you need to first calculate the molar mass of this empirical formula. So that based on this calculation, we have 2 carbon, 5 hydrogen, 3 nitrogen. So that's 71.1 grams per mole. And then we can calculate N. The multiple is the molecular formula's molar mass is given 213 divided by the molar mass of the empirical formula. So that is 3. That tells you in the molecular formula, there are 3 units of empirical formula. So the molecular formula will be the empirical formula multiplied with 3. So multiply this to the each subscript. The molecular formula will be C6H15 and 9, because 2 times 3 is 6. 3 times 5 is 15. 3 times 3 is 9. Okay, actually for this kind of question, if they tell you the molar mass of the molecular formula and tells you the mass percent of each element, you can use another easier way to solve the problem. Here, you see I copy paste the same question. Now, you can do this. You can just use the molar mass multiply with the mass percent of each element. For carbon, is the molar mass multiplied with the mass percent of this carbon and divided by the molar mass of carbon. You can calculate the number of the subscript for the carbon. And then you can calculate the mole of hydrogen is the molar mass times the mass percent of hydrogen divided by molar mass of hydrogen. 15 will be the subscript of hydrogen. The last one is nitrogen. Use the molar mass multiply with the mass percent and then divided by the molar mass of nitrogen, and you can calculate the subscript of the nitrogen is 9. So then you can quickly find the molecular formula is 6 carbon, 15 hydrogen, 9 nitrogen. Okay, so that solves the question. The question is how to find the molecular formula. If the question also asks you to calculate the empirical formula, you can still calculate that based on the molecular formula. So for example, 6 to 15 to 9 is not simply as the whole number ratio. The factors apparently is 3. So you can divide by 3, then you can have C2H5N3. That will be the empirical formula. Okay, so that's the way to do this kind of question. So if you have any questions, please let me know. Okay, good luck.